Good evening, everybody. Stephanie Brown here from Intelligent Construction Opportunities. I am really excited for this particular live stream. I have, as you can see on the screen, Antigone Sharris. She is the program coordinator of the Engineering Technology program at Triton College in Chicago. And I ran into her through my work with Bring Back the Trades a little bit, as you saw one of our posts. And so we began a conversation. And what impressed me so much about Antigone was that she really understands that there is no difference between a 4-year program and a 2-year program. They are just getting you to different things in a different path in a different way. So welcome, Antigone.
Welcome. Good to talk with you, Stephanie. Thank you for having me on.
I am very thrilled. So before we went live, we were talking about a little demo as Antigone was giving me of a welding class that she was doing. So Antigone, do you want to sort of take it away and sort of tell the audience a little bit about what you did to actually figure out chrome casting? And
Sure. One of the things that we always talk about is the use of technology in our environment. A lot of people think that using tech means using a tablet and, oh, we're going to bring iPads into the room or we're going to bring Samsung tablets or whatnot. And in my case, I'm in a welding lab and there isn't a lot of places to connect. So one of the things we were trying to solve was going wireless in an environment that you might damage something rather expensive. So instead of getting one of those high-end smart boards and whatnot, I just went and said, hey, there's got to be a better, cheaper solution. So we ended up picking up a couple of the Microsoft wireless displays, and we actually put them in all our labs, not just the welding lab. So, and we have the Apple TVs. So essentially anybody with a cell phone or anybody with a computer, whether they have an Apple device or a Android or laptop, doesn't matter, can literally cast onto our screen. So as a group, we could see what's going on. And what I routinely do is take my phone and I'll bring it to one of our welding booths and I'll talk about with my camera about something and they're seeing it on the big screen. So we don't have to have a big crowd of students just standing around one welder. They could be sitting at their station and I could be projecting right on there using my cell phone. And the parallel that we were talking about, Stephanie, was how on a job site, if they're at a construction site and they have a tech like this, they can actually even like video conference or video chat with somebody and show them, hey, this is what's going on here. Is this correct? Is this what you want on this job site? So that's an example where tech can transfer.
And again, I asked Antigone to do this because the whole premise of tonight's live stream is how is construction technology going to affect future building? And what does that look like? So as somebody that has coordinated a program where using SolidWorks and AutoCAD and robotics and CNC are just a normal thing, we want to kind of talk about how those tools are used and what kind of students can be turned out knowing how to use the technology and where those applications might go. So again, I guess maybe the best thing to do is maybe focus on the two areas that your programs cut off into. Let's explain to the audience a little bit about what those are. And then we'll start talking a little bit about the tech applications, but also the practicalities of it all.
Our curriculum at Triton College is in engineering technology where we have technically 2-degree pathways. One is mechatronics, the other one is mechanical design. And the mechatronics is more getting into the robotics and automation side of the house. And the mechanical design is more on designing the things that are being automated. Is one way to think of it, but designing anything, whether it's like in this space, they'll be designing things that are welded. In our electricity class, they're designing things that require electrical systems. And we do an integration as well, where students in the two classes can actually, if the same student is in both classes, they can cross over their designs. They can build in this room what they're designing in another class, like AutoCAD or SolidWorks or Inventor. So we teach across the board. So the student, as I like to call it, and I do it visually, I want the student to be a multi-tool. The ultimate multi-tool that any company, I know, I got to use my Leatherman here, any company can use. I'm very visual, so when we talk, but I end up taking everything out. But I want them to be employable by anybody and to have complete portability in what they do. And whether they get a certificate or a degree doesn't matter for me personally. For them, I do always recommend they go all the way so that they have that in their back pocket for when they need it. Because the last thing I want any of them to be told is, no, you can't do that because you don't have XYZ degree or XYZ education. But those are the long-term goals that we have for our students, is to maintain, I call it sustainably employable for their entire lifetime, not just for the moment. So it's never about the short-term goals, though we have them. Short-term goals start here, and then progressively, who do you want to be, and move themselves forward. And whatever they need to acquire in education, because we're their partners, I like to say, education is really the person's partner in their professional development. So as they progress in their profession, where can we help them? And if it's not us, then, it's their bachelor's program, whatever it is they need to do.
So let's get a little specific here. Don't name names or whatever, but can you give some examples of over the years of a path that has been followed?
We've got, we have students in 3 different states that I personally know, and some of them have moved strongly into automation. Some of them are actually working for construction companies. I've got one who was a science school teacher, taught grade school science, came to us because they wanted to change careers and got into a company. She works for a construction company right now, and she does the CAD drawings there. So,
okay. You want to talk a little bit about CAD and explain a little bit for those in the audience that may or may not know a lot about CAD and sort of how you position it when you begin to teach this?
CAD is computer-aided design or computer-aided drafting, depending on who you talk to. And that it can be CAD or CADD, computer-aided design and drafting. So it can go all the way. And what it is, it's essentially a glorified pencil or pen. You still need to know what you're doing. So in our curriculum, we actually make sure you do hand drawings as part of the process. And on the CAD side, we typically work with either Inventor or AutoCAD because those are ubiquitous in the marketplace. AutoCAD is a product we stress because it is pretty much number 1 on the planet. And it's something you need to know if you plan to work at any company related to engineering, construction, doesn't matter, architecture.
So give an example. I mean, I could call out a company I'm working with in New Hampshire, Granite State Manufacturing. They make submarines, right?
Yep, Aria Group Architects in Oak Park, for example. We've got Interlake Mechalux that does lights off rack system designs for facilities for fully automated places. And Interlake, they hire our students to do their AutoCAD work there. So those are just 2 local places that I can rattle off. But it's LK Manufacturing, they use SolidWorks, but a foundation in AutoCAD is fundamental to them as well, but we teach SolidWorks as well. And LK, if those of you are in architecture or construction, they're the stainless steel manufacturers, as stainless steel sinks, water coolers, drinking fountains. So you've probably used an LK product in most buildings. They're out there.
Now, what's the difference, again, explaining to our audience the difference between SolidWorks and AutoCAD? And why you teach both, or why those are foundational programs?
We teach all 3. AutoCAD, which to me is like Excel for accountants or Excel for anybody in business. It's ubiquitous. It's something you need to know. Inventor, which is an Autodesk product, is a 3D parametric-based CAD product that allows you to dynamically design and will generate not full detail drawings, but really close detail drawings for projected views for production purposes. Inventor is for us what Revit is for architects. So they allow you to get into the three-dimensional realm of construction. And then in SolidWorks came out of the injection mold industry, but it is a very, very good product for 3D parametric modeling as well, like an Autodesk Inventor. It has an absolutely awesome rendering tool bit, which I like better than Inventor's tool for rendering and giving you animation. But Autodesk's tool, they're getting better, but I still have to say SolidWorks is better on rendering.
So it's like anything else. I mean, the tools are similar, but they're just better at certain things, each of them.
Yes, yeah. I'd still say Inventor is very good for sheet metal design. Now, I come from the stainless steel industry, so that's kind of why I do have a preference there. SolidWorks does a good job. It's sheet metals, it's okay. I'm going to say today, though, most decisions are made based on what legacy. I would have to say, what do you have in your house already? If you don't have a 3D CAD product at all, which way do you want to go depends on how much you want to pay and who do you want to go with. So I teach both and I know both and I love both products. So I wouldn't be the right person to tell you. I can tell you what one doesn't do versus another, like mano to mano. I can show you the processes and you decide whether or not you like it one way versus the other. But generally speaking, you can't go wrong either way with SolidWorks or Inventor.
So how do your students absorb that? How is one easier or less easy to learn? And is there more math required?
Neither. Both of them allow you to put math equations inside of them. So no, they're both on par. So if you learn one, you can pick up the other. Like in my case, I learned Inventor and picked up SolidWorks. So that's how I was. I learned AutoCAD first, and then I learned another product called CADKey that gives you a little background, and another product called SDRC. So these are
CADKey,
older products, right?
Yeah.
And then once I had that foundation, the rest was just learning where the buttons are, as I like to call it.
It's true.
Because foundationally, they're all the same.
Yeah. So sort of is a nice segue into math. We'll sort of back up a little bit into your programs. So in terms of preparing students for, graduation, these are 2-year programs we're talking about right now, correct? Your mechanical design and your Mechatronics robotics. Well, first of all, do you see a particular favor of student wanting to enter one or the other? And if so, what are their leanings that they find themselves choosing one over the other?
Well, when it comes to what the program attracts, where do students start? They don't start with the degrees. We have certificates that you could get done in one semester. So within a 15-week cycle, for example, our welding certificate that I teach in this lab, in 15 weeks, you're done with a certificate. You don't have to go on for anything else. So it's not really a 2-year program. You can treat it as a 1 semester, one and done, and that's it. When you want to come back, what's nice is the coursework in our certificate, they call it stacking, is the language they use, is actually, to me, I like to say it's packed into the next certificate, which is the design certificate. And then that's packed into, the whole family's packed into the degree. So you don't have to think about your associates till whenever you feel like it. You can get stuff to get you going now and then move on. We're not the only community college that does this. So we have to appreciate that all the community colleges across everywhere, not just in the United States, but also like we talked in Canada. And Australia, they have a community college system there as well. All of us do the same thing. So I think of us as a group, as a family, if you want to think of it that way, where a person can come in one semester and secure gainful employment skill sets and then move on and do what they want to do.
So
and in
give
our
an
case,
example. What would they do? Is it so they finish? Yeah. They've got a what you say?
Well,
18 weeks under their belt in welding.
Yep. So in our case, one of my guys already started, and we're in March, so he didn't have to wait 15 weeks. I got picked up by one of the companies already. The nice part is our curriculum, just like other people's, but I'll speak to ours, is designed to teach you the drawing, the math, the welding, the blueprint management side, not CAD. We don't get into CAD in the certificate. It's bite pieces, okay? What's it going to take to get you employed now? So I always like to say, get into the trades now. Don't wait. There's no reason to do some weird, expensive curriculum somewhere else. Just do it at your community college. If they got a welding curriculum, go after it. It's low-hanging fruit opportunities for getting into the marketplace. You can get into inspection. You can get into the fabrication side of the company. You can go work for a manufacturer of anything. The skill sets are transferable. They're very useful in a variety of positions. You can even go into maintenance, because in maintenance, part of the job is repairing things, which involves having to weld things together. So it is a great entry point. And we do have a lot of students that'll start in welding, and then they'll continue on into their design pathway. And we have some that go for robotic welding, because we have that as well. And they want to go and become the programmers of a piece of equipment that's going to do the welding, and then they get into robotics completely and go into automation.
Well, trying to stay on our theme of building for the future. So I want to talk a little bit about your Mechatronics and the robotics. So who are you seeing go into those, and what do you see as the market demand for robotics, and where are you seeing that?
The demand, the students that are coming in are usually coming in, of all things, ironically, they're coming in for the certificates in electricity, and they're coming in for certificates in welding, and then they become aware of the robotics and the robotic welding. Oh, that's kind of the way it's happening. People are not coming in for the degree and picking it up the other way. The majority of them are coming in through certificates and then seeing what they can do with it. Wow. And as far as the marketplace, once they get picked up by a company, if they go into maintenance positions, they're going to go after PLC, which means they go mechatronics.
Can you explain a little bit of because to me that's the new language of robot. That's the language of robots.
Programmable logic controls are ubiquitous as well in anything from smart buildings. When you want to make a green building, you have a lot of automation that helps make it green. When do you turn the air conditioning system on? When do you turn it off? When should you turn the heating system on? When should it turn off? If you want to make the building as smart as possible so it takes care of itself, that requires PLCs. If you're looking at solar panel technology, that also you've got a panel that has controls in it, Johnson controls, all the fun stuff. You're getting into that side of the market. Some are hard-coded, some are remotely programmed, but at the end of the day, PLCs are behind the whole conversation, controlling the entire system on the back end. It doesn't have to be a physical control system. It could be a digital type control system.
What kind of programming are we talking about when we start talking about PLCs?
Our focus will be Allen Bradley's. That's what we focus on here. And those systems control any type of automation system from the shop floor to building systems that are certain parts of the building systems will involve baby versions of a PLC. So they're everywhere. And the idea is for our students to be, how shall I phrase this? When they come in for welding, we force them to embrace technology because they don't want to. They're like, I just want to weld. And I'm like, I know you do. But guess what? The world is not just about welding. Welding is just a piece of what you do. There's the prep work to get to welding, and then there's the post work. Welding itself is a tiny piece of that entire conversation. And there's a lot of checks and balances. You got to look at the blueprints, you got to lay out drawings, you got to set up the jigs and fixtures, then you actually weld. And then you have to measure everything along the way. Then you get to the post end. And then they have to embrace tech, they have to embrace the math, they have to embrace measuring, the whole 9 yards. And once they've gotten past that, a lot of them see, hey, wait a minute, I can get that better paying job over there. I'm like, yeah, go for it. And so then they want to go into robotic welding. And then they're like, hey, wait a minute, robotics is everywhere. It's not just in welding. I'm like, you're correct. And then they get into the whole family. There's cobots that are out there. There's automation. Just go to the store. When those doors automatically open, that's automation. When you go to the grocery store, when you use the scanner to check out your groceries, everything is automation. And once you realize that, you're like, holy cannoli, it's everywhere. Yeah, it is. We're in everybody's business.
So can you talk a little bit about maybe 1 or 2 star students that really got it, came in, didn't understand really whatever, and then started eating it up?
I'm not going to call her out, but I guess I am. Elma is one of my students who've taken it all the way. She came, waited for her kids to do their schooling like all moms do. We always put our kids first. And then got her schooling done. And once she got that, she took off, and she's an automation engineer right now. Wow. So Fern is my other guy. He came in as an accountant. And he was good with numbers, but he's like, I just kind of like working with my hands. What can I do? One thing led to another, and now he's in sales. So he's doing the sales engineering side. So one went automation program. The other one went more for the people part of automation, which is interfacing with clients.
What was the time trajectory of doing that, particularly for Alma?
Alma, I think, took 3 years, I think, for her to get through the curriculum because she was working full time and had the kids. And Fern was the same. He had the same scenario of things going on with him.
So it sounds to me like they were both more mature. Is that fair to say?
True. I do get a lot of students who come back, and I always like to remind people, your future, how do I say it? Education, we're your partner in your professional development. So you come back when you need to and use us whatever way you need to.
All right, I want to swing a little bit over to tech in general now. Doing a little bit of research myself for this, I was really quite interested in well, a couple of things. Certainly robotics is becoming, it's not ubiquitous yet, but I do think there are enough companies working behind the scenes that the labor deficit and shortages and even just the grueling work, certainly of construction, robots can certainly stave that off. Where do you think the line is between a robot being properly programmed, so much so that it can do the nuanced work of a very experienced tradesperson?
It doesn't exist.
Exactly. Thank you.
Correct. Yeah. And I don't think it ever will. Of course, I'm a fan of I'm a sci-fi fantasy person, so I can think of all the examples of like Battlestar Galactica and other shows where we have robots taking over and becoming autonomous, totally autonomous. The computational requirements are not there yet. When they become sentient, not if, I'll be honest, I anticipate that happening. The question is, what are we doing with ourselves to make sure we don't obsolete ourselves in our own environment? So I do always think about that. But as far as today is concerned, or at least within, Moore's law tells me this is going to happen, just mathematically. But if we think about,
but what would it take for them to be sentient, though? I think that becoming sentient is exactly what's missing from too many of the wow, correct. Isn't that cool?
Correct.
Conversations to actually make them feeling is.
That's, I don't see it happening in our lifetime, but I can be corrected on that in the future. That's okay. I don't see it computationally. I don't see it happening because of it's a quantum level, and I don't want to get into all that. That's a little too deep for me, but I'm not quite sure that we can get there. And that's good for us, as I like to say. The fact that technology is not perfect is to our advantage, because that's where we come in, because we're the ultimate problem solvers. There's the human element. And we see things that robots can't see. I can look into space and find the one little speck of something that's off that a robot can't, because it's focused on looking at everything in a different way.
To me, it's a difference between being programmed and not being programmed.
Correct. I agree.
And that's when people perhaps in construction think, well, what's the point of learning that trade? The robots are just going to end up doing it anyway.
No, if that was the case, I wouldn't have a welding program. In fact, I was speaking with someone recently about the evolution of education. And the reality is we need those foundational skills that people think are not important, like using a ruler, measuring in inches and millimeters, knowing how to do math in your head. Boy, the schools have done us a disfavor there with introducing calculators too soon. How to measure fractions, how to do math with fractions on your ruler. There's a whole set of things that are missing in foundational understanding, because people think, oh, you're not going to need to know that. You don't need to know how to use a pencil. You don't need to know how to write. Everything's going to be typed. And here I am every day writing. And when you're on the job, wherever you are, whether you're at a construction site or in an office, you're not always going to whip out a tablet and type to the person next to you.
Well, I was sharing with you, Antigone, before we got on the air, that I was reading an article about BIM and an architect that basically said he thought that in some ways BIM was destroying architecture. And the one thing, and this gets back to this whole conversation that's so deep and long about being sentient or not, is we intuit things. We intuit things that we don't even know we're going to intuit. I mean, I can wake up, any one of us can wake up and think one thing, and then somehow something comes in your midst and you're like, that's what I'll do with whatever. But you wouldn't have known that 20 minutes before.
Correct.
And that, to me, is a part of why, no matter how many algorithms you feed, no matter how much Chat GPT and algorithms can suggest and, mishmash all the encyclopedic phrases and information out there and start to understand how to match them, it's not always. Sometimes it is. If it depends on us, I'm not going to deny that on a simplistic level, you can do those things. But when you're really talking about solving things that are complex, I mean, it takes a certain program to have figured out all those variables to have possibly then allowed that program, that robot, that whatever, to find out maybe what a human would have found out. And maybe they're doing it faster, sure, because those algorithms are there, but it was still human knowledge that had to allow that to happen. And then, well, I mean, I'm not going to go down that tunnel either, that rabbit hole of war. But I mean, war is made, war is not just made factually, right? We don't decide to go to war because this is that and that is this. There's a lot of emotion that drives all war, if you ask my opinion. So,
but specific to like chat GPT, since we're getting into it here at the college, and you can use it to even possibly debug programs. And you can even use, there's other tools out there to help you with your video graphics and everything else. And they're all only as effective as their programming, as their inputs. And true, like humans, the more inputs you have, the better you can decide whatever it is you want to say. And you can say, tell me the history of the Industrial Revolution to chat, and it'll give you an entire essay, but it's based on content that's pulled off the net. What it's not going to give you is that personal touch of like Stephen King novels, where it takes you into the story because of not simply the act of the English language being used or whatever language it's translated in, but it's how it's used and the use of the wording. It's like when I watch certain TV shows because I like the dialogue and how the characters interact with each other. I look at artwork because of the blending of colors and the look and the feel, not how deep do the colors look, not necessarily it's a painting. There's a lot more to that piece, and that's where I don't think automation will win.
It's
in the sense that over us.
It's subjective.
Oh, yes.
And automation is programmed to be objective.
Right.
And
correct.
And anyway,
it's not subjective. It doesn't choose one way or the other because of it'll look better in this light. It's not going to be able to interpret that.
And yet technology, so I'm just going to ramble off. So, there's in terms of what continues to be on the precipice and is not yet the norm, but is working its way. So blockchain in construction is certainly coming along. To me, drones are in some way old hat. If a contractor can afford to have drone in any circumstances, whether it's for safety or whether it's for remeasuring because, some material didn't fit that was prefabricated and came on scene and, whatever, drones to me are a done deal. It's like they're not going away, and nor should they, because they are so much more efficient, particularly with the labor deficit. Augmented reality, in varying degrees of, I think it's got a long way to go, but, is just starting to find its proper use cases, I'll say. Robotics, we've touched on 3D printing. There's contractors in China that say they can produce one house for $5,000, and there's printers now that are large enough to be able to pull off 10 houses in a day. With housing shortages and homelessness, that's important. Well,
on the subject of 3D printing houses,
go for it.
There's a small issue with that, and that's a function of there's a lot of pre-planning that occurs with that. And if that architect that you were talking about has issues with BIM, 3D printing will totally eliminate the on-site, can I change my mind and move the window there? Gone. It'll create, I'll call Mies van der Rohe style construction.
But you know what? You bring up a really good point that was just coming off of our last segue, which is, sometimes architecture is just plain ugly. It's just plain ugly and, shouldn't exist because it's so ugly. And yes, maybe the project came in on time and everybody got paid and moved on. But what will your city culture look like? What will your town look like if it all turns into cinder block architecture? So
it won't be cinder block. It'll just look like poured concrete
Well, that's kind of where I was. That's kind of well, like it just came out of a sand pail, you know.
Yeah,
You
yeah.
know,
It's,
sort of.
I mean, it's interesting, but
But that's why when we talk about technology, we're not going, oh, technology, all of it is fabulous, 100%. It's all great. It's all fantastic. The future's without any flaws. That's
no,
where, to me, the human element and all these books that are written time and time and time again that, you know, I mean, humans are bring something to the table that unless you want to completely I don't what's the word I'm looking for, help me, Antigone, a very robotic, a very
automated society.
an automated society where you
Cold is the word that comes to my mind.
And non-emotional, I guess, is the truth.
No flair.
Then fine, you know. I mean, certain people like Elon Musk talk about, you know, let's get things set up on Mars and we'll start shipping up giraffes there tomorrow.
That off-planet stuff I have always said is very good for us, and that is another area where automation is a very good tool, because you're not going to be able to send a lot of people out there, but you can send a host of bots out there to start working on basic construction and whatnot to get things going. So I do believe there's a place for automation in environments that are inhospitable, in terraforming, getting things to a point where then people can come, and then you go from there.
But that's the big, for me, that's the big bridge. And then you go from there. What does that mean, right? Do I want to live in a, you know, in a purified box, but I'm on Mars and there's no poor weather conditions? I mean, you know, we are going down so many, you could go down so many rabbit holes. It's not even funny. But then I'm going to get back to a little bit of practicality here. I noticed today that there's something called self-healing concrete that repairs itself after severe weather conditions. So when cracks start appearing from extreme heat or extreme cold, there's self-healing concrete, which I thought, well, that's pretty fascinating stuff. There was also paint that changes color, and it's based on the thermal heat around itself, which I thought, wow, the HGTV would have a ball. Well, today it's going to be this color, and we have put heat panels, solar panels on the wall now. So if you decide you want pink walls tomorrow and yellow walls on Tuesday, it's for you. Sometimes I feel that that channel does such a disservice to construction, but anyway. That's just me.
I'm hoping.
Smart roads too. I noticed smart roads today, and I thought, well, okay, if we're going to have self-driving vehicles, to me that they should.
Oh yeah. When it looks, sensing where your vehicle is at any given time is a project in and of itself. So I'm not concerned about truckers losing their jobs or the roads, you know, you're basically being hands off for the entire trip. I certainly don't want to lose the wheel. I like to drive. I don't care much to be, per se, the passenger. So I enjoy doing that. So those things I don't think will go away. I do think the automation will help with some of the navigation. Obviously, we all use, who does not use Google Maps? Hello. We all use that to get around. I don't think anybody knows, and anybody born after 2000 knows how to use an actual map. Oh, sorry, I'm not going to talk about that. There's a whole set of things being lost while we are foundational skills, sadly, foundational skills getting lost while the tech is taking over. Knowing where the sun is, understanding where it sets and rises, and being able to figure out which direction you're going in. Am I going north, east, south, or west? That kind of stuff, understanding your environment. Those kind of things are getting lost with the tech, which is annoying, but it is what it is. when it comes,
I'd like to kind of wrap here, though, Antigone.
yeah,
I think
go
that's
ahead.
a really good place to wrap, because what I'd like to do is talk about what is being lost in another session, and what does a particular generation of young people, you don't have all young people, and I respect and appreciate that, but for young people, what is their purview in terms of the tech that they use and what they expect to learn? And we can put a pin in this for the next time, but I really think about what is being lost and what can't be solved for some assumption that I'll find it on Google. Right?
Correct. They're at the core, they're losing the ability to think. That's one of the things I'm observing, because I'm trying to get them to use their tech in a thinking way, not just to get them the answer they want in the moment, but how to think beyond that moment. They have to type a question in to get an answer. And I'm like, no, kind of just see what rabbit hole you can go down and type in a question, but then see where else you can go with this. And then from there, come up with your own solutions.
So, you know what you're making me think of? I mean, what this all comes for me is that then I'm starting to think that tech needs to be incorporated in school, but not in the way that it is.
Oh God, yeah, I can agree with that one.
Right?
Yep.
Right?
Oh yes.
That's what's missing, is that, you know, Christmas comes or birthday comes, and it's like, Mom, I want an iPad. Mom, I want a whatever. Here you go. Okay, now you got tech. You're good. Right?
Well, what are you doing with it? You're playing video games on it. You're not using it as a tool to learn new things. You can search online and find answers to a bazillion questions, but you don't know. Like, for example, they'll say, oh, I don't know how to use a ruler. I don't know fractions, Ms. Sharris, they'll say. And I'll be like, well, go to Khan Academy, go to YouTube. What? Yeah. By the way, go to YouTube, you know, and they're like, use tech to become better educated for yourself, and then teach yourself how to learn and how to think. And that is missing. So I tend to try to discuss that in class and also outside of class, how to think for yourself, because you're not always going to have the tech in front of you. So you have to learn how to use what you've learned and the situation you're in to come up with solutions that are not found in a textbook and not found online. You're looking for real answers to questions that have not been answered.
Well, and also it's the context of your life. The context of your life is unknown. Whoever is in your classroom today, where they were 15 years from now.
Yeah.
So what you want to do is be able to contextually use tools, contextually use information. And that's what's fundamentally missing from how we're taught, period. I mean, I won't right now, but I mean, you probably be very shocked at my own background and my own lack of formal education, but it's all come because I had a curious mind.
Correct. And that's the key. If you're curious, no one can stop you if you want to learn. But if you don't want to learn, the smallest thing can stop you.
Well, but the thing about learning is that it falls into the cliche of lifelong learning. But the truth of the matter is, I can guarantee anybody who's younger than myself that what you thought you knew then is not what you know now. And your world gets more refined because you have what I say is less windshield and more rear view mirror as you get older.
Exactly.
And that windshield, it looks like a huge window now, and that rear view mirror seems really small, but the inverse happens as you hurtle through your life. And that to me is why the disservice is done, that learning should be contextual. It's contextual to your life.
Correct. It used to be, I hate to argue. I mean, I wrote an article about the value of certain amounts of education on LinkedIn over this, where I kind of questioned where education came from, where its birthplace was, how it was contextualized historically, and then how it turned into what we deal with today. And architects weren't going to school to become architects. It was a trade. Same for accountants and everything else, and same for what we do. And it turned into you have to go to a school, and I question how much schooling.
Well, again, I mean, I have to say it, you have ignorant people leading ignorant people. And at some point, that lemming you call it a lemming because it is a lemming. Anyway, we'll end on that note, but we will put together a few resources, Antigone, to share with those that registered for tonight and seem to have a passing interest in this. As we all know, live streams are, what they are. People can come on live, or they can certainly enjoy some form of this post in a post recording setting, which I will be providing. So with that, I can't thank you enough. I want to do this again. I think there's so many different circles and ways to go after this, and I do think, like all things on the net these days, you just can't kind of barf out a subject and leave it there. It's an evolution of conversation, and you gotta, to me, it's like a tight string. You gotta hold the string. So I hope to be able to do that with you down the road. And once again, thank you so much for this evening.
You're welcome.
Everybody else who tuned in, and we'll call that a wrap. Thanks.